Captain Peter Cutsey, South Korea. This is my briefing room. Today's presentation is on the stepping zones. What are stepping zones? There's something that I've come up with to better allow pilots to better appreciate the importance of what to do when close to the ground if encountering, let's say, an engine malfunction right after V1. It's important to understand the closer to the ground you are, the more critical, and the less should be said. So I've broken down the zones into four: a red zone, an amber zone, a green zone, and a blue zone. Those colors reflect the importance. So the further you are away from the end of the runway, the safer you are when you're busy doing things such as aviating, navigating, and communicating. We're at Gimhae International Airport, Busan, South Korea. This is a Lido present overview of the airport itself. The PowerPoint that we're going to use during this presentation is called Stepping Zones. Let's have a look at what I've done. We'll have an overview. Red zone, amber zone, green zone, blue zone. Let's go and have a quick look at the red zone. Flying the airplane close to the ground, we've got a little prompt here. And basically, if you have a problem after V1, let's say an engine malfunction, and remember that there are several engine malfunctions. When we talk about engine fire, severe damage, separation, we're talking 3. When we speak about limit, surge, or stall, we're speaking about 3 more. Then we have engine overheat. Then we have a flameout. So right there, we are talking about 8 different engine malfunctions. And it is of critical importance that the pilot monitoring, who really is the most important person on the flight deck, in my estimation, not the person flying, in what that person doesn't say or says close to the ground. So the pilot flying is going to fly the airplane and keep the airplane straight. An engine failure or an engine problem, enough rudder to center the control column and track the extended center line unless told differently with respect to engine out procedures that are dictated by your company or your airline. So these are little tips that are in several of my library. So let's go back to the main menu and let's go ahead and have a look at that first zone, the red zone. I call it because you're close to the ground. It is from field elevation to a minimum of 400 feet above field elevation. If you notice, I said a minimum. First thing, fly the airplane. This is pilot flying. Pilot monitoring, cancel any bell or lights as applicable and monitor the pilot flying. Pilot flying, use rudder inputs the way I described to you earlier in this briefing. Rotate at 1.5 to 2.5 degrees per second towards 12 to 13 degrees of pitch. Not my words, the manufacturer's words. And it's important that it's done that way. Then follow the command bars. Track the extended center line of the runway unless directed to turn. Well, how are you directed to turn? Not from air traffic control, but from your company standard operating procedures if there is a specific engine out procedure. For instance, we are on the center line or the threshold of runway 36 left at Gimei International, South Korea. You can see the terrain up in front of us, it's quite high terrain. Well, airlines that fly out of this airport actually have created through their engineering department and in unison with ATC, an engine out procedure that in this particular case calls for an immediate turn once over the departure end of the runway. I won't describe the entire procedure to you, but here's the end of the runway. And if you notice, the actual route that we are programmed to fly follows that. But in any case, you would follow the engine out procedure as specified by your company SOPs. In other words, the turn could come before 400 feet, depending on how heavy you are and how hot it is outside. If you're at a high altitude airport and you're heavy and hot temperatures, you're going to be turning well before 400 feet above field elevation. So back to the PowerPoint presentation, we'll slip over to the next zone, which is the amber zone. Now, the amber zone, the way I call it, is from 400 feet minimum above field elevation to 800 feet minimum. Instructors teaching you how to fly during your training should not use a hard number, especially when it comes to engine problems or malfunctions of any sort close to the ground. We're going to be speaking specifically about engine malfunctions today. That's why I'm using the term minimum. So let's see what the first thing is. Well, we have two different scenarios for the amber zone. We have a simple scenario, which is at 400 feet, pilot flying would call for heading south. Pilot monitoring would select heading south. Pilot monitoring would push recall to bring back any of the problems that have occurred in the red zone, such as a fire bell, overheat lights, fire lights. All those would be brought back into action. Pilot flying and pilot monitoring would identify the malfunction and do the recall items as required. That is the simple amber zone scenario. Now there's one a little more complicated. Pilot flying, pilot monitoring. Pilot flying would say, call for heading south. Pilot monitoring would select, heading select. Now, if the engine out procedure, such as the one we just spoke about in South Korea at Gimei International, required a special engine out procedure, pilot monitoring would set bank limit as directed. Perhaps there's a limit on the bank angle. Could be 25 degrees, such as Salzburg, Austria, off of runway 15, and we'll have a look at that in another video. Or it could be 15 degrees. Whatever is dictated would be set as directed. And then the pilot monitoring would open the speed window because you have to maintain the speed at the time this happened. And it has to be between V2 to V2 plus 20 for an engine malfunction. And then pilot flying would turn as directed as specified as per engine out procedure. Then the pilot monitoring would push recall after the pilot monitoring was happy with his or her duties. The pilot monitoring's duties are to monitor the pilot flying, not to talk, except airspeed, heading, pitch angle, anything critical that the pilot flying is not doing his or her job. It's up to the pilot monitoring to speak about those things. But below 400 feet, nothing else, I believe, should be said. You follow your company SOPs. I'm giving you 65 years of experience, and most airlines will follow what I'm saying now. Because if you say something and it's the wrong thing, you will mislead the pilot flying and you could cause a crash. So, say nothing except for the items I just spoke about until you've definitely identified the problem. That's the pilot monitoring's job. The pilot flying is busy flying the airplane. Okay. So that's why push recall comes a little later in this scenario. And then identify the malfunction and do the recall items as required. One little item here I put in a note. If turning at V2 to V2 plus 20, do not clean up until wings are level. So if you have a turn, you don't clean up in the turn until your wings are level, which means until you're finished turning to the departure point you're going to in the engine out procedure, whatever it happens to be. Let's pop into the green zone. Phew, things are getting better. Pilot monitoring and pilot flying confirm VNAV path and speed bug moves up. If you're VNAV equipped, and most people flying 737 NGs and the MAX today have VNAV installed. Or if flight level change, set flaps up speed and clean up. If you notice, I have the identifiers of pilot flying and pilot monitoring are both involved in this. After flaps up, lights out, set max continuous thrust. All right. Let's pop over to the blue zone. The blue zone, I've broken down into two scenarios. Returning to the airport, the departure airport, or continuing to an alternate. So let's look at the first one. This is MSA and above. We're in the blue, and we're now in a safe sector. Depending on your company SOPs, you can put the sector, critical sectors on the fixed page by looking at this particular chart. For instance, the Lido chart that we're looking at, the 270 radial and the 180 radial and the 090 radial. You can put those on the fixed page, knowing that the most critical sector, as you notice, is this sector here, 5,200 feet, MSA. All right, that's just a tip. Let's go back to the PowerPoint. Return the bank selector to auto before selecting LNAV. Now you're in the navigating portion of it, all right? At the very beginning in the red zone, you're aviating. You are navigating as far as the extended center line is concerned, but you're not going to any particular point except straight ahead. So if you don't return the selector to LNAV and you are given a vector, you could only have 15 degrees of bank for the turn if the engine out procedure called for 15 degrees of bank. That's why I've introduced it here. If returning set hold speed, your flaps up speed will be very, very close, if not the same as your hold speed. That's a tip. And hold close to the airport if at all possible. Of course, what happens if you lose the second engine? Heaven forbid. If maybe the engine flameout was due to fuel contamination, well, you certainly want to be over the airport at a high enough altitude to be able to land if you lost the second engine. Airmanship. And remember, you can hold at any point using the FMC. Do a quick DODAR. If recall items are not done, do them. Let's say you forgot to do the recall items. Well, you want to make sure that they are done. So you can use an acronym called DODAR that actually will bring you through to the fact that, have we done the recall items? All right. It's very easy to forget the recall items, especially if it's an engine surge or limit or stall. Enter the hold. Once you're in the hole, call for the first non-normal checklist. When you've completed that, do the after takeoff checklist, then continue on and do all other non-normal checklists as required. All right. We're assuming now you're coming back to land. Do the one engine and operative landing checklist as required. If it's involved because perhaps your problem was an engine problem, down to the deferred items, and that will be the last checklist. Once that is done, prepare the aircraft for the approach and landing, then complete the deferred items. Let's look at scenario 2. Scenario 2. Proceed to an alternate airport. Return the bank selector to LNAV before bank selector to auto, I should say, before LNAV. Climb at the engine out speed to the engine out altitude, which will be prompted on the CDU. Get a clearance to do so, of course. And you should really have it done in Route 2. Do a quick DODAR again. If you forgot recall items, do the recall items. Route 2 should have been loaded, I've got here, should have been loaded with the alternate. That's a time saver. You don't have time to type in a route. Activate and execute it. So that would be the pilot flying's duty to call to the pilot monitoring to select Route 2, activate, and once the pilot flying confirmed and liked what the pilot monitoring was going to execute, the pilot flying would issue the command, execute. All right. Then call for the first non-normal checklist once established after the navigating process has been completed. And as in scenario 1, do the after takeoff check, then continue and call for and then continue. Now remember, we're assuming here that the after takeoff procedure has been accomplished. Then complete all other non-normal checklists as required. And then do the one engine and operative landing checklist. This would be somewhere en route to your alternate. Down to deferred items, that would be the last checklist. Then prepare the aircraft for approach and landing. Of course, set up the approach and make sure all the bugs are set the way you would do in a normal operation. Then complete the deferred items. Well, there you go. Red, amber, green, and blue zones. Enjoy your flying. Stay professional. Captain Peter Cutsie, this is my briefing room. Thanks for watching.